Hi, and welcome to this module in the Titration video series. We're going to be covering the security dashboard and the associated forensic events and forensic capabilities of Titration. So in a lot of other modules in this video series, we've been looking at the way that it's possible to define segmentation policies using ADM and go ahead and enforce those segmentation policies to ensure that you can't have any unnecessary lateral movement in your environment. Now, alongside that, we also believe that you should be doing things like vulnerability assessments and also analyzing the behavior of the processes and users that access your applications to make sure that they're not doing anything that is non-compliant at the same time. So to do that, we're going to be using our security dashboard and our forensic analysis engine to achieve those results. So let's take a look at that, Remi.
Let's take a look. Just actually, before we start, is that a licensed feature I have to buy aside?
This is not a licensed feature. Everything comes under the Cloud Workload Protection license. So as long as you've licensed the workloads that you're monitoring, you're going to get that segmentation, you're going to get that visibility into vulnerabilities, and also the capability to do forensic analysis.
So in short, if I have the agent deployed and I have my license for that agent, I actually have all the features out of the box we're talking about. It's not an additional license you have to purchase, it's part of what you have.
Yes.
Cloud as well?
Cloud as well. And that's also applying to any workload anywhere and all of those different workload types that we've discussed in other modules.
Very cool.
So what I have up on the monitor here is my security dashboard. The security dashboard is really your one-stop shop to get a good handle on how your data center is doing from a security perspective. It is trying to help you track over time how healthy you're doing. Have you started to see some new vulnerabilities in your environment? Are we seeing malicious processes? Are we seeing servers listening on ports that they shouldn't be doing? All of that is going to contribute to this metric up here, this overall score. So B, overall score, what do you think about that?
I honestly believe you cheated.
What, to get a B?
Yes. I think you cheated, but not well enough.
Yes, that sounds quite a lot like my education. So there we go. We're at a B. That's okay. I mean, we could do better. We could do worse. It's not the end of the world. This is where we actually see a lot of organizations are at when they first deploy Titration. You know, the world's not on fire. It's not like everything is vulnerable and that we're seeing lots of non-compliant traffic, but we could also take some actionable steps to increase that to a potential A or even an A+ score. So what are the different metrics that go down into this security score, Remi?
But even before I go there, like your point, right? I mean, I'm sure you cheated anyway, but that's off the point. I noticed a good trending though.
Yeah,
because that's pretty interesting from a trend standpoint. While I do agree, B is nice as a score, and if you're at school, it's like, oh yeah, B, A, whatever, it's important. Point is here that you actually increased your security posture pretty dramatically across the last few months, a few days, man.
Yeah, and that has been because we've basically been following through these different modules in this video series to apply the different protections that Titration offers to us to increase that score.
So I think that's a good thing from a management standpoint, dashboarding standpoint. If you want to actually prove and show and monitor progress in tracking towards security, that's actually a really good place to start, because you could see very well Tim did not have any kind of segmentation here. You can see that it was the bottom color here. And you can see that as he added that, immediately his score just shooted up.
Yeah. Yeah. Okay, so what are the different pieces of the score that we're looking at here?
I see 6.
Yeah.
I count right?
You counted right.
Okay, I can go to daycare.
I'm sure they teach you to count in France at least.
To some extent.
Okay, so looking at the vulnerability score here, this is one of the first parts of the metric. This is basically assessing the workloads that we have visibility into the environment, looking at the packages that are installed on those workloads, whether that's a Linux workload or a Windows workload, and comparing that against threat intelligence feeds to warn you if you have known vulnerabilities. Seems kind of simple, right? But does that save people sometimes?
Well, I'm pretty sure it should.
Yeah.
I mean, we're talking about things that might have been there forever for whatever the customer knows.
Yes.
They might be owned by other teams. Other teams have their own management software. They might not be looking at that metric. Mm-hmm. So potentially giving this kind of global metric is pretty useful. And I'm sure there's ways to dig into much farther into that.
Yes, and we'll look at how you can dig down. But it's actually a common fact that a huge amount of exploits are well known to the security team, or at least are well known to the industry before a customer is breached using that attack vector. So just basic cleanliness of patching and understanding the vulnerabilities that you have in your environment is a good way to get a grasp on what's available there. You know, we've seen a lot of high-profile enterprises breached based on known vulnerabilities. It's not like we're talking about a 0-day here. This is something that everyone knew about, and they just simply either didn't have the capability to the patch, the way or the time to patch either.
No, absolutely. Yeah. But another thing you just mentioned in there, you mentioned the notion of thread feed for updates there.
Yes.
So, I mean, on Titration as a service, it's easy. I mean, I guess that's taken care of for me.
Yep.
That's usually
it's in the cloud, so everything's happening in the cloud, right?
Exactly. Love it. On-prem.
Yes.
How do I know if it's working?
Let's take a look at that, actually. So if we come to our security tab here and look at our threat intelligence section, we are going to see that the Titration cloud connection is active on this cluster. And you'll see that by the fact that it is green and it's showing the automatic updates are active.
Perfect. So green, good. I can see de-installed. I can see some failed there as well, but I know we had a licensing issue with our ASA. That happens. If I don't want internet access to my cluster, I mean, you might have some situations where internet access isn't acceptable. How do I handle that?
Yeah, so you are capable of uploading the threat feed manually. So you can upload a manual threat dataset, and we publish those on our cisco.com website. It is also something that you might want to think about when you're configuring your cluster, which is to provide a HTTP proxy so your cluster can access the internet, right?
Okay.
A lot of clusters are deployed with inside data centers, which require the use of a HTTP or HTTPS proxy to access the internet. So we do recommend you configure that because it means you'll get the latest threat intelligence updates automatically.
Can you show us them? Because I'm pretty sure that, as usual, you logged in as a site admin instead of using your user account.
Yes, absolutely.
I mean, things are predictable with you.
So here we have underneath company, we have outbound HTTP. So here, this is really where you can choose exactly what the cluster is going to do. So we're firstly saying that, yes, we do want to actually generate those outbound HTTP requests. So if you would like to stop your cluster from doing that, you can always switch it off. It is really a preference of the end user. But if you are using a HTTP proxy, then you would click that, put in the details of your proxy, and then this cloud connection is actually going to update. You can see the test HTTP proxy button down there. So unless you have a particular reason to not use the threat intelligence feeds, I would highly recommend you just take a minute to go look at your cluster and see if you've configured this HTTP proxy, because it's going to bring you a load of new automatic updates on the fly. So it's well worth taking the time to look at.
I believe if the customer is looking for HTTP URLs to whitelist, that's part of the product documentation as well, right?
Yes, it is.
Perfect.
So knowing that we have...
Don't forget to remove our HTTP
I should
proxy,
do that.
please.
Or else we're going to be trying to look for an empty proxy.
Yeah, it'll be interesting.
And then we can come back to our dashboard. So our dashboard here, we've spoken about the vulnerability score, and we know that that is using a threat intelligence feed to look for vulnerabilities in the packages on your workloads. What about the process hash score?
Process hash. So, well, I'm guessing and that requires a software agent.
Does require a software agent.
My understanding of process hash is there's lots of things that are actually inside the process hash. So one of the things in the process hash is we want to understand similarity between systems. You have 10 servers, 10 instances of bash running across those servers, 10 Nginx running across those servers. Your security standards probably dictate which version you should be using. Nginx is probably statically compiled, it's probably tested, validated for your environment. So you want to make sure that works. Now imagine that out of those 10 servers, 8 were running one version of Nginx, 2 completely random versions were part of that. Mm-hmm. That could be multiple things. Could be a developer that decided that it's a good thing to test with live traffic. Fair, can happen.
Sometimes.
Could also be someone that actually replaced the binary, an attacker.
What, they've taken a legitimate-looking binary, replaced it with their own binary, and they're masquerading as that process on the workload.
Exactly. And those things are pretty hard to catch if you don't know what you're looking for. So that's one of the ways you can do that.
So it's kind of like an odd one out assessment.
What?
An odd one out assessment. You have 10
That's
processes.
Saying,
it might be a British one. Odd man out, you could say that as well. Looking at the one process that looks different than the rest of its sibling processes.
Yeah, absolutely. It's finding the outlier, in short.
Yeah,
I prefer my more limited English, Tim. I'm sorry.
I'm sure there's a very beautiful French phrase to describe it as well.
It has food in it for sure.
Okay.
So that's one of the areas, but there's more to that.
Yeah.
The other thing is that you can actually yourself whitelist or blacklist processes. So you can say, hey, I've seen this binary hash. It's running on this sets of server, and I know it's bad. I don't want it there. I can blacklist it, and I will actually drive the score down to 0 for some workloads.
Okay.
So that's a pretty cool one. And the third one is thread feed.
So what would the thread feed be doing?
So thread feed is actually, that one does require the HTTP connection. I mean, you cannot do that offline, but the HTTP connection to the head end allows us to actually go and check that a process hash, is not a known malware, and returns back a verdict to the machine.
So Tetration is going to take a hash of the binary of a process. It's going to send that hash securely to our threat intelligence, and our threat intelligence is going to give some sort of verdict. Either this is a known good binary, or it's a binary that we don't have any information about, or it's a known bad binary. And do the end customers have to pay for that? Is that something that is separately licensed again?
No, it's all part of the cloud license.
Okay.
Cloud workload protection, to be precise.
Oh, that's very interesting.
So all this comes out of the box, and also while we send the hash, we don't send the file. So there's no detonation or anything, or risk of privacy to be lost there.
That's good. That's good to know. So we've got the process hash score down. What about the attack surface?
And that's my favorite by far.
Okay.
So the cool thing about, I think attack surface is probably one of the most underrated features of Tetration.
Okay.
Like, how do you secure your workload? What's the 101 of securing your workload?
Well, you should try and lock it down.
That sounds logical, right?
Yeah.
So how do you know if you can lock it down if you don't know if a port is actually being used on a server?
It's that famous NTP problem again.
The famous NTP problem.
So, when you deploy a fresh new server, let's say I deploy a new version of Red Hat, it's going to be listening for a lot of different network connections that might not necessarily actually be needed by that server, right?
Absolutely. So how do you detect those? And again, big data comes into play, because if we have a large set of data, we can tell you did this port, ever see a connection in its life.
So we can go see all of those processes that have active sockets, but are just sat there idle, not actually receiving any network traffic to them.
Exactly.
Okay.
Well, that I think is very useful in terms of a platform, because, it's a lot of manual work to get there.
So this is going to give us like a list of the workloads that we should actually go and think about applying segmentation on, or potentially even stopping those processes listening on those sockets.
Yeah,
okay,
absolutely.
Now, we've got the forensic score saying NA here, and that's because we haven't yet gone into the forensics part of the system, which we're going to get to later in this module. But this is going to be able to let us see exactly what, Remi?
So forensic score is alarm-driven, to some extent, behavior-driven as well, for some other items inside it. The idea is that you arm a set of rules, and we offer you a pre-canned set of rules as well that rely on best practices. And those canned rules are then going to be triggered by specific behaviors. When they get triggered, they will actually ding your score. So if you have a score of 100 at the beginning, and you hit, for example, something that you determine be a very high severity impact, your score might go down to 50 or 0. And we'll talk more about that a bit further.
Let's get to that soon. So we have forensic scores, and then we have network anomaly and segmentation compliance scores.
Yeah.
So network anomaly. I'm assuming this is something to do with network traffic, right?
There must be a bit of network, right? We collect so much network data, let's make something out of it, right? So the logic is baselining. So if we see a server, this server is sending 1 gig, it's receiving 100 meg. Normal pattern, 9 to 5 pattern. In the morning, from 8 to maybe, 10, there's a spike of traffic for users connecting, and somewhere around 7 p.m. it goes down again.
Okay.
That sounds normal pattern for most enterprises today.
Yep.
If this 1 and 100 meg actually get flipped, and imagine that now it's actually sending out 1 gig and receiving 100 meg instead of the opposite.
Ah,
So that could be data exfiltration.
okay. So let's say that Bear gets access to one of my web servers. They use lateral movement to start exfiltrating data from a database, and they're funneling that out through the web server. The web server suddenly stops being a server and more of a client.
Yeah,
That kind of behavior is going to drive a decrease in the network anomaly score.
exactly.
Okay.
And that's not DLP. That's the beauty of it. We're not trying to replace DLP, data loss prevention, or anything like that. The goal of that is really to say, look, there's a massive volumetric anomaly in your system. And the big breaches we've seen across the last few years have had those kind of massive data exfiltration.
So we're talking about noticing those really big changes. This is a whole database worth of information that we've just exfiltrated
Exactly.
out. Okay, that's cool. And then, so that's more on the anomaly-based detection. Compliance sounds a little bit more concrete, right? This is something that we've looked at in a lot of other modules, and that's around tracking the compliance of the segmentation engine compared to the policies that we desire to be in place.
Sounds good. That's exactly that.
Yeah, okay. So let's go delve a little bit more into each one of these different parts of the forensic dashboard,
Sounds
the security dashboard.
I'd say maybe keep vulnerability for last, then we can actually show them the nice and advanced version of...
Yeah, let's do that. So let's walk down to some of the interesting ones, like the attack surface score. So for example, under attack surface score, I can look at the workloads that have the lowest score.
You did it on purpose, Tim.
I did it. And what's the lowest score down there? Oh, it's a brand new, freshly deployed Windows server, and it has a bad attack surface score.
Thank you, Tim.
Just saying. Well, what you can see actually, and this is important to note, is that the lower the number, the worse the score is. So 0 means that you have a very bad attack surface. You have lots of ports open that you don't need to have open. If your score is 100, that means that you don't have any ports open that you're not actually actively using. Make sense?
Makes sense.
And that's across all of the metrics as well. So if we open up this one and choose CentOS 7 v2, I'm going to see some information about this workload. So it says there are 4 total ports, and 4 of them are unused.
That's interesting.
So we're listening on port 22 for SSH. We also have something systemd listening on port 111, and we have RPC bind on 955. So we can actually see not only the port that's listening, but we can see the process that is associated with that port, the interfaces that it is listening on, and if that process is related to a system package, we can actually see the package that that process is associated with.
So you raise a point which interests me. You're talking about interfaces.
Yeah.
So does that mean I can actually figure out a process like SSH listening on link local on IPv6 because I forgot to disable it?
Yeah, which is a very, very common misconfiguration.
That's very good.
So here we could start making some active changes. We could go and disable OpenSSH server on port 22. Or if we don't have access to that workload, which is often the case, we can start applying segmentation policies to stop this workload from being able to receive connections on port 22, because realistically, it probably shouldn't be receiving SSH connections.
I mean, that sounds fair. So you're saying that either we give the information to the system owner to go and make the change and disable the port, or we virtually patch it?
Yep.
That's pretty cool.
Yeah. Okay, so we've looked at the attack surface. Now we can take a look at some more detailed information about the individual workloads. We could look at the processes that we capture on those workloads and the packages that we capture on those workloads. Sound reasonable?
That sounds really interesting.
Okay. So let's come over to our software agents over here, and we're going to pick a workload that looks interesting. So, I don't know, what about one of those CentOS boxes again? Let's go back to that CentOS here.
Okay.
So here we're on the workload profile. And the workload profile is kind of the command center, everything that we know about this workload, and we can start interrogating some of these different features. So let's take a look at the process snapshot. Ooh,
That's a fancy graph.
that is another fancy graph there. So,
What am I looking at, Tim?
well, apart from this tree-like structure, I can explain a little bit. So what we're seeing here is a snapshot of all of the processes that are currently running on this workload. So for example, I can see that we have QEMU running on that workload. We have the titration sensor running on that workload, some of which we've even noticed have vulnerabilities associated with them. We've been able to see that there is syslog-d running on this CentOS workload, and we've also compared that against the CVE database, and we know that that version of our syslog-d has a known vulnerability. Pretty cool, right?
It's pretty cool, and I see vulnerability seems pretty high as well.
Yeah, the CVSS score, the V3 score there is 9.8, so you know
Out
what?
of how much?
Out of 10.
Yeah.
So 9.8 out of 10.
98%, I mean, it's not bad.
Yeah, not bad. So we should probably do something about that. You know, we could ensure that our syslog-d never is allowed to receive or generate network communications.
That could be a good start.
Not only that, we've also taken a copy of that hash. So we've taken a hash of the process and we've looked that up against our threat intelligence feeds. And that would be able to inform us if we know that this is a known bad binary. So that's the distinction there. This binary is not actually bad. It is a real version of our syslog-d. It is just known to be vulnerable to a certain exploit. It still is the legitimate version. If that R syslog-d had been replaced by a bad, unknown version of that binary, that's where the binary hash would come into play and give us that extra level of visibility that, hey, something looks wrong here. Okay?
Not bad. That's a cool feature as well.
And again, whenever you see this slider down here, you can play things back and forth. So it's really like seeing a DVR, which means that I can see the order that processes were launched and how they forked child executables as well.
Pretty cool. And colors have a meaning as well, right?
Colors do have a meaning. So you can see that anything that's highlighted in the green color is privileged user. That would be the administrator on Windows or the root user on Linux. And anything that's in blue is a user that is non-root, essentially.
Okay, also it's pretty easy to track down which ones should have your attention. The one I see straight off the bat is like, okay, you're at the top of the pyramid, you have all the processes running from you,
and you
seem to have a vulnerability.
Yeah. So this really is a good way to track the vulnerabilities on your workload and get a good grip on what you should start patching first. Okay, so we've been able to look at the process snapshot, and we can also look at the long-lived processes, which again just gives us the same type of information but graphed slightly differently. And it's also going to give us some metrics about those processes. So for example, we can see the CPU usage of a process and also the memory usage, and again the binary hash of that process.
And you can see the score and the source for the hashes if there's anything to report.
Yeah, so we can see that this process here, this Anacron process, has actually been whitelisted. We know it's a legit process, and the anomaly score is 100. 100 being high, meaning that it's actually safe.
Okay, higher is better for this one.
Higher is better, yes.
Okay.
Okay, so we can see the processes running on the workload, and we can see if they have vulnerabilities. Let's actually look at the packages that we are collecting. So you see some packages here, right?
I see a lot of packages.
Yeah.
312.
312 packages. And this is just a fresh installation of CentOS. There is a lot of packages that you have to manage on every single workload. Too many packages to be managing by hand in many ways. So by being able to really understand the packages, analyze them, and look for those that you might need to be patching and updating, it takes a lot of the manual work out of the process.
So show me a bit. I see package list. Great.
Yeah.
I can do RPM-Q and get that on CentOS. What should I look for in this list?
So the things that you really want to look for are those that have the little warning icon next to them.
Okay.
So you see the warning icon here. What this is actually saying is that this version of this package has vulnerabilities.
Okay.
So I know that this util Linux has vulnerabilities, and by clicking this, it's going to take me to the vulnerabilities tab. It's then going to pre-populate that query for me with util Linux equaling the package name, and it's going to show me the different CVEs that are related to that process. And if I wanted to, I could actually click the link here, which will take me to the NIST database, which will show me a full description of that CVE and give me the relevant information that I might need to know about why that vulnerability applies to me.
Very cool. So we're moving from a place where we have the segmentation of the platform. And we saw all the segmentation. We've talked a lot through segmentation. Then from segmentation, we move to understanding the security posture. This is which ports are being exposed unnecessarily to other networks, other systems across the environment. Then we move to looking at what is running on those systems. Is there anything, a bad hash? Is there anything I should be worried about? Then we track all the packages running on the system as well to see, okay, is there any known CVEs? Is there any issues I should be careful of on this platform? And we've done all that without leaving this UI.
Without leaving that one single pane of glass.
That's impressive.
Yeah. Now, let's say that we have a known package that's vulnerable. We know that we have a vulnerability and we want to patch our workloads as fast as possible. But you know patching, right?
Complex.
It's complex. There's a lot of moving parts to packaging, especially if you're factoring in the application. Sometimes it's just not simple as saying update your dependencies. It's going to cause a whole workflow to go through to ensure that those dependencies can be updated. So we need to come up with another way to understand that there's a vulnerability, apply some level of control, but not push that all down onto the developers to fix it right now, here and now.
So are you back to virtual patching?
Back to virtual patching.
I like that.
And that's what we can provide with Tetration. We can use our policy engine and our knowledge of the packages and the vulnerabilities on those packages to actually apply segmentation rules to virtually patch workloads, take them off the network, or at least apply some level of quarantining so that they can't access the most valuable assets in your data center if they do have known vulnerabilities.
Could you show us?
Yeah, we can definitely do that. So let's say, for example, we have this util Linux package here.
Okay.
It actually isn't that vulnerable, but we can use it as an example about how we can pull this package out and apply some policy to it.
Yeah, it doesn't seem that nasty.
Yeah, it's not the worst, but we have a good environment here where there aren't too many vulnerabilities. So what we might want to do, for example, is apply a policy that would work at the global level. So we can actually write a segmentation policy that is based on that package or a vulnerability or a CVSS score. Make sense?
Makes sense.
So let's come to our global policies. And if you have watched our module on policy ordering and hierarchy, you'll be able to understand a little bit more about how these policies filter down into every workload in the environment. So what I'm going to do is create an absolute policy, and I can use that absolute policy to deny something. Now, what should we do?
I mean, seeing the kind of vulnerabilities we're looking at, maybe we want to just deny them outbound access.
Sounds about right. So how about we do this? Let's create a new filter to select vulnerable workloads. Now, how are we actually going to define those workloads?
Either, I guess, we could put CVE score, or we could actually use the package name.
Yeah, in fact, we could use any one of those different variables, and we could actually put many of them together to come up with a composite query. So let's just start putting this. I'm going to say the package info could equal util Linux, if I remember that's what it's called. So there we're going, and we say that there are 26 inventory items that happen to have util Linux on them. So I can say for those 26 inventory items, you are not allowed to generate outbound network access.
Yeah, but so I'm looking at that. I get that technology is pretty cool, but in that logic, I might be blocking workloads that actually have util Linux but are not vulnerable, right?
Yeah. So we could even go ahead and add some more different metrics down to this as well. So we could say that you also have to have a CVSS on your workload, and that CVE score has to be greater than, I don't know, let's say 9.8. Oh, maybe let's go for 9.7. So it looks like we also have workloads that are vulnerable to CVEs greater than 9.7 as well. And that's because a lot of workloads actually do come baked in with some vulnerabilities when you freshly deploy them. But you can keep adding more attributes to this query to keep pulling it down tighter and tighter until the point that you're comfortable with the workloads that you're going to restrict network access on. In fact, if we look at all the properties available to us when it comes to vulnerabilities, you can see it's actually very, very detailed. So not only is it the package info or the package CVE or the CVSS score, but we can even go to the level of understanding what is the type of vulnerability. Is it a vulnerability that requires local adjacency? Or can I access that vulnerability over the network? How hard is it to actually execute that vulnerability? Is it pretty simple, or would I need to be an advanced hacker to get in via that vulnerability? And so you can see all of the different attributes that you can use here.
So I could use, for example, here, Access vector network and complexity low. That sounds pretty risky at that point, right?
Yes.
So those ones that we should really focus on, especially if they're accessed from internet.
Yes. And what's really neat is that just like every single other policy object in Tetration, they're going to be continuously updating. So if I bring a new workload into my data center that matches any of this criteria, if it has a known vulnerability, it is automatically going to have this policy applied. At the same time, if an application team goes and upgrades their dependencies so they are no longer vulnerable to the particular vulnerability that we're looking at, they will automatically be allowed back onto the network. So by putting one policy in place that describes the vulnerabilities that you would not like to have in your data center, you are being watched 24/7 for compliance with those vulnerabilities.
That's pretty cool.
Yeah, it's really nice. It actually will help you sleep better, right?
Yeah, I mean, definitely. Especially as you can tie them to scopes, so you can actually be restrict to DMZ, for example, or stuff like that.
Yeah. And think about this, if you're using that cloud connection where we can pull the latest vulnerabilities down dynamically, if there's a new 0-day that's released sometime in the middle of the night, that's going to be downloaded by Tetration automatically. And if you have the right policy set up and you wish to do so, it can dynamically apply that new virtual patch to stop any workloads potentially leaking data during that window.
That's pretty cool.
Yeah. Okay. So we've looked at the ability to use vulnerability information to lock down workloads and proactively quarantine them from the network if they have known vulnerabilities. And that really covers off a lot of the cleanliness, the hygiene of your workloads. But unfortunately, that's not going to always stop every single determined attacker. There are going to be scenarios where they are still able to get into your application. And at that point, it's really nice to be able to start using the forensic analysis of Tetration to watch for behavior changes at that application level.
The other thing I'm curious about, because I see lots of stuff with that attack vectors and stuff like that. So
Yep.
Before we go to forensics, is there a way I can get a sort of composite view across the vulnerabilities in my environment in a way that I can have a look and see which ones I should focus on?
Yes, yes you can. So just like we have a dashboard that is looking at all of the different security metrics, there is a specific dashboard for vulnerabilities. So this dashboard is just focusing on the vulnerabilities that you have in your environment. And you can bring that dashboard down to any sort of scope.
I
so
like this.
Here we're looking at the cloud scope. And yeah, we're saying right now across the cloud environment, there are 402 vulnerabilities that we have on our workloads, and these vulnerabilities are remotely exploitable and low complexity. They're the ones you really want to watch out for, right? Whereas the high complexity, not easily exploitable, those are the ones that you might get around to later to patch.
I mean, if you're at locally exploitable complexity, you're talking about either a physical security problem or someone breaching your hypervisor infrastructure.
Yeah,
so
exactly.
Definitely you'd focus on these two. Yeah, remotely exploitable, low complexity, I would definitely have a look at those ones.
Yes, you really should do. Okay, so we have that visibility, and now let's start looking at what we can do with forensic analysis.
Yeah.
So forensic analysis is underneath the security tab. And before we look at what the forensic analysis shows us, let's take a look at the configuration that we can apply. So I'm going to pop up to the root scope here. Okay, I'm actually going to change over to this tab where we'll find our forensic analysis, and we will look at our forensic configuration here. So the forensic configuration allows us to define those so-called tripwires that you were talking about. These tripwires can set up different parameters to look at, different events that you might see on a workload. And when you see that event, I want to either alert about it or I want to record all of the actions that that particular user took once that event was triggered, right? So what are some of the different events that we can see here that we have configured?
So I can see there's a few things configured. I can see stuff around shellcode execution. That seems bad. I mean,
Yeah.
just off the bat. Shellcode, okay. I'm surprised it's not immediate action, it's just critical. So, okay. The privilege escalation as well, pretty bad as well. So that means that we can track sequence, see if we're looking at privilege escalation, right?
Yes. Yeah.
That's pretty cool. So, but I see those things are manually, I mean, I can see difference in formatting. So those ones are definitely manual set. Is there anything canned for me on that? Or?
Yeah, absolutely. So there's around 28 rules that come out of the box, and they map to the MITRE framework. So they look for a number of patterns that are well used by different exploits to get access to a workload. So if you're not really comfortable, and we'll see the kind of configurations that you can apply, there's going to be a load of out-of-the-box filters, or I should say forensic configurations, ready for you to apply to your workloads that are going to protect you from some of the most well-known exploit chains. And these are written by the Tetration engineering team. And we're constantly updating them and pushing down new canned rules that you can have applied to your workloads based on the experience that we have from analyzing lots of different environments.
That's pretty cool. I like when people do the work for me.
Yeah, I like that too. Do you want to come around here and finish the rest of this session?
Don't push too far.
So let's click Create Rule. Create Rule is just like any other part of the Tetration system where you're going to give it a name and then build a clause to do something. But in this case, what the clause is it's going to look for behavior on that workload. And let's see the different types of behavior that we can look at. Well, here's a list of some of the things that we can pick up. It's things like a file is changed. Data is being leaking out of this workload. Users are logging on or giving privilege escalations. Shellcode is being executed. Commands are being seen that we've never seen before on this workload, or users are being created or deleted. Those are very interesting events, I think, right?
Yeah, definitely. Plus, as you can do sequence in events, that makes total sense. I mean, I could be looking at, I think, user logon. You can even say if it's interactive or non-interactive. So I could see user in logon, which is non-interactive to a session and that kind of stuff. That gives us lots of information.
Yeah, look at that. We can say, I want to catch all events where users log on to my workload. And I want the user logon to be via a password, via a public key, or via SSH, or if it's a Windows logon, is it going to be interactive? Is it going to be in a RDP session? Whatever you really want that particular event chain to be, and you can obviously use all of these at the same time if you want. It's then going to record every single action that took place after that point in time. Files being accessed, executables being launched, processes forking. Those kind of things are going to be stored, and then you can replay them after the fact to see what happened.
Okay, that's pretty cool. You just have to admit Windows has more options in this case.
Windows does have more options just for this particular event, but I promise you there are some really nice events that we can apply. Some of which get very advanced, like being able to detect things like Meltdown or Spectre, right?
So, show me.
Okay, let's take a look at what a forensic event generates.
Could you show me the config of the Spectre one? The Meltdown, sorry?
Yeah, in fact, here we have one over here. So, either the event type is side channel, and the source is either Meltdown or Spectre. Very complicated, right?
That's all?
Doesn't require a PhD.
Definitely not. I'm sort of disappointed.
You want it to be more complex?
I mean, look, that's security analyst. You have to make your.
Okay, you have to justify.
Yeah.
Okay, I get it. I know. Well, if you don't want to have complexity in your life, here is a really good way to protect yourself against side channel attacks, especially if your engineering group has said we can't afford to patch this particular set of workloads because we can't take the performance trade-off. You can still go ahead and apply this side channel monitoring, and if someone were to be actually executing a Meltdown or Spectre type attack on that workload, you would still get the forensic event and you'd be able to deal with that in appropriate measures.
That's pretty cool.
Yeah.
So we have a demo of that in action now.
We do. And again, you can think of this in a way of virtual patching.
That's pretty nice. By the way, I forgot to ask the question, but all those stuff predefined, manually defined, and so on, I can apply them per workload, per scope. I can define when and how I apply them. All those options are open to me, right?
Absolutely. It is exactly the same as most of the other parts of Tetration, which is where you build the profile, and then you apply the profile to a set of workloads based on an intent. So here we're saying apply the profile AWS to all of the workloads in AWS, and that's going to trigger the rules privilege escalation, unseen command, and shellcode.
That makes sense. AWS is my front-facing servers. I might have a different set of rules for those AWS servers, but maybe I don't care of having them on my backend servers. So that's pretty cool.
You can choose to tweak the levels of the types of forensic events that you're capturing based on the type of workload that you're looking at.
Okay.
So let's look at forensic analysis and look at some of the different things that we've seen. So if we pop over to here, we can see something that we captured back in January. Look at that.
January.
Yeah,
Wow.
that was a distant memory. So here we have some events, and these events are showing us that on a workload in AWS, which is where we configured these forensic rules, we've seen some shellcode executed. Now that's interesting enough, right, that there was shellcode executed and it was shell that executed that code, but let's open this up and see exactly what the forensic event shows. Whoa.
Okay.
Right. So, how about we read through this and see exactly what we're seeing on the screen?
I forgot my popcorn, Tim.
Yeah, this is going to be interesting. So we can replay this from the start and step by step through.
Go on, show me.
So we see system D.
That's normal.
Yeah.
I see green. Green is root.
Yep.
Okay.
There you go. I am root. And here we can move to...
You are root.
We can go to the next one. Oh, I'm going to pull that back. My bad. We can see the Java process. So
Okay.
system D launched the Java web server. In this case, I believe it is a Tomcat web server running the Apache struts application.
The great Java, I see.
Yes, I love the way that Java just has all of these lovely options. So
I'm impressed the whole command line was captured.
yeah, the whole command line with all of the options, which might be useful during forensic analysis. Did someone change the command line options before we were breached? You know, it's useful information to have. So we can see that the Java process is there. Java process is something that we expect to be on this web server. That's actually part of the baselining that the forensic analysis engine performs to understand the day-to-day behavior of this workload. And we know that that Java process is fine. It's in blue. We're not panicking about it.
Okay.
However, the next event is interesting. So the next thing we see is a executable in a temp directory running under that Tomcat web server.
Can you show me more details on this guy?
Absolutely. So I can take a look at that particular executable. Now that's starting to get interesting. That name of the executable, I mean, it's as bad as the Java one, but it looks more suspicious than the Java one.
Yeah, plus .exe on Linux.
Yeah, usually uncommon to see that on Linux.
Yeah,
So something's going weird here, and Titration's definitely monitoring
That's
that.
fishy.
And then the next one is really where things start to kick off.
Yeah.
So here we can see it goes red, and that's showing us that, wow, there is some shell code being executed under that Java web process, and that's really, really a bad sign at that point in time. A web server executing some shell code, bad things are happening. So, what did it do?
I need to know, because obviously people are going to ask questions on that kind of event. It's like, what did the attacker do? What was it after? Which kind of data did he manage to access? Did he get anything out? All that stuff.
People are definitely going to be starting to ask questions. So we see the shell session launch, and then we see the shell session launch make.
Shell.
Yes, that's a mouthful.
Shell,
and
yeah.
I'm natively speaking English, so.
I've given up on that.
So we can see make here, and we can see exactly what make did. How about you walk us through that?
Yeah, this is an interesting thing. Can you hover on the make? So very interesting. So it seems from what I see, dash J2, so he's trying to get concurrency. So make has been used to get concurrency from the command line. You can see that. Gzipped a tar file. He created a weird string. Can you click on this guy as well? Yeah, you can see he actually used a command to generate a random string based on a date. And he's been doing that like probably to generate some form of key. You can see that he tarred a folder. I'm guessing the folder he tarred the folder was gzipped after. And he curled the file he created here. Can you show me the curl command?
I can. Wow.
Okay, so you can see that he actually posted to some form of random French website.
Is he, you in this case, are you attacking my web server?
I don't see what you're talking about.
It even says, show me the money, Remi. Come on.
It's a misunderstanding. Yes, absolutely. So, Tim, show me the money if you want your password back.
There's nothing valuable on that web server. You can have it.
Damn it.
And you can take that to the bank.
There is a point, actually, which is interesting, is that the attack actually failed, if you look at it. Notice one common thing.
Okay.
What's the username?
Tomcat.
Which means I never managed to escalate privilege.
Ah.
So that's the very interesting part of this output. If you go back to the previous page, click on the tar folder, Look at the folder was tarred.
That looks like a privileged folder.
He tried to tar a folder to the PC Tomcat. There's probably a temp folder in there. There's probably some jar files. But if I didn't mess up and I didn't put my credentials in the file, there's most likely nothing really sensitive there. So yeah, did the breach go through? Yeah, it did. Did he roam around my system? Yes, he did roam around my system. Did he manage to get to the important data on the system? It seems he didn't. So what should you say? You wake up, the CISO is asking, what happened, Tim?
Yeah, well, I can at least show him exactly what happened. And we can understand how bad was that breach? What is the impact? What type of data was lost? Do we need to start preparing our plans to talk about this? And most importantly, we're going to have all of the rest of the titration features kicking in at this point. If this workload is having policy enforcement enabled on it, then it's not going to be able to let that attacker get deeper into the network. We're also going to have complete visibility via the flow data to see exactly how much data was sent out from this workload once that breach happened. So we can really correlate a lot of sources of information together to get as much information as possible in that one pane of glass.
Very nice.
Yeah.
Out of curiosity, can you just expand towards the end of the attack? I'm curious to see what happened with this file.
Go through. So, sleep.
Okay, that's probably not a trip, some kind of security of like too many process forking or something like that.
Seems reasonable. And then what happens here?
That's why the key was generated.
That's really where they want to show you the money. So here, what's that, GPG?
You could go up one and you'll see that, yeah, he's basically passing the file to the start input of GPG.
Okay, nice.
That's pretty nice. I mean, you literally have every single command that were typed in this specific event.
Okay, even if that command might be showing you the key that they use to encrypt files, for example.
Yeah, and this file, I mean, interestingly, so the attacker used the file this way, it was, they didn't show up in the history, so we don't know what's the password, but we actually managed to know everything that happened from now on.
Yeah.
So,
very useful.
Pretty useful.
Okay.
So that's one attack.
What about Meltdown or Spectre?
I like Meltdown. Show me Meltdown for a change.
Let's take a look here.
Spectre is a fancy name. It's been used a bit too much now. Let's show a bit of the Meltdown. Meltdown is really cool.
Meltdown is really cool. So that's what we're seeing here in this event. So we have the command listed as Redis server, the host name being node 4, and that's making me think Kubernetes, perhaps.
There's a pretty high chance in our environment.
And then we're seeing that the event type is a side channel attack. So let's crack this open and see what we can see. All right, slightly more linear history here, but let's walk through it as well.
Lots of root in this one as well.
Lots of root. So we can see systemd at the bottom. Remember, everything is tracked in a forensic event, not just once the forensic event happens, but everything prior to that forensic event as well. So we can see that there is systemd, which then launches dockerd. So yes, this absolutely must be a container here. So we can see the...
I hope at least.
Definitely, I really hope. We can see the Docker container run, and then inside that run, we see Redis server.
Okay, why Redis? Why would Redis trip Meltdown?
Yeah, that's a good question. So let's take a look. So it looks like legitimate Redis. It's listening on the Redis port, but it's still claiming that it's a Meltdown attack.
You know what most likely happened? The attacker took the Redis code on GitHub, and because it's a container, that's what's making me think about that. He changed the GitHub code, he forked it, and probably said he fixed a bug. He said, oh, fix bug X, one of the top bugs of Redis, and he made that inside his branch. People take it, and unfortunately, lots of developers do not look into the detail of the code, so they just go and they execute and they compile and they build the container. Container can go through static analysis, static security analysis. Nothing will be flipped there, neither, because it's pure code that's inside the box. When it executes, then it triggers Meltdown. Redis is memory intensive. No one will be shocked to see Redis using a lot of memory in an environment. So he can be nicely dumping memory on the container host, memory from all the containers, potentially all the VMs running on that host if it has not been patched. and you would probably never know it.
That don't sound good.
That doesn't sound good at all.
Okay, so what you're saying is like in a situation where someone, maybe got access to our build system or managed to infiltrate one of our desktop machines and was able to slide in some code that really shouldn't have been there, but no one noticed it, and they deployed it into production, Tetration is still going to be able to see the fact that, hey, even though it's named legitimately, it looks legitimate to you. Actually, under the hood, it's doing something very different, and in this case, it's actually executing a meltdown attack to exfiltrate data.
Exactly.
And that's in a container.
That's in a container.
And this is supported.
Yeah. Look
So
at it.
I just run that software agent inside the container, do I?
No, container host.
So I don't even have to modify my container images to get that protection.
Exactly. And that you get runtime protection across the container host. That's
so
pretty useful.
even if I have build time protection that's looking at my container images and scanning them, it still makes sense to have this runtime protection to even catch some things that might slip through my build time protection.
Exactly.
Okay, that's nice. So we've seen an event on a virtual machine in the cloud, and we've also seen an event on a container running on top of Kubernetes. I'm pretty much sold on this now, Remi.
I think it's pretty cool. I think we literally covered everything there.
Yeah, okay.
Very nice.
So we've gone through the security dashboard that shows you all of the different composite metrics that we put together to give you a security score, including vulnerabilities and process hashes. We understood how we could use that information to apply segmentation policies in the environment to perform some level of virtual patching and protecting ourselves against some of those known vulnerabilities. We've then been able to configure some forensic analysis rules based on the behavior exploits or the behavior of the workloads, and then we've been able to see what's happened during a forensic event. Pretty cool, right?
I think we nailed it all.
Yes, we did indeed. So if you'd like some more information about Tetration, please visit cisco.com/go/Tetration.